Okay, and we're back and we're going to talk some more about those residuals. So that's the difference between the actual dot on the graph and that same point down below on the line, so our predicted value. So again, we're doing our residual is our actual minus predicted. And so when we're looking at our scatter plot, if this is my prediction line and these are my dots, then my residual would consist of this difference right here. And so my predicted value is here, my actual value is here. So if I do actual minus predicted, I get a positive residual. So anything above the line is a positive residual. And what that means is that we have underestimated the response. So this is what we estimated, and this was the actual. And so our prediction was underneath it or underestimated. Now a negative residual would look more like this. So here's a negative residual. So this. So here's what actually happened, and here's my predicted. So because my actual number is lower, because it's below the line, it's a negative residual. And if I were to take this lower number and subtract a higher number, like 8 minus a higher number, I would get a negative residual value. And that means that we overestimated because my predicted value was over what that actual point is. And so a lot of times they're going to ask you to look on your graph, mark that residual, and in fact I've seen this on past AP Stats tests. Draw the line for the residual, and people who don't read the directions lose points because they just didn't draw a line for residual, and then talk about it. So remember, if that residual is above the line, it's positive. If it's below the line, it's negative. And then think about it. Is my prediction higher than the actual one? So it's an overestimating. Or is my prediction lower? And so I'm underestimating. So we're looking at the relationship between that prediction and that actual value. So we have an actual sample problem, and this is back to a track. We're comparing sprint time to long distance jump. And our regression equation takes sprint time and is looking to see if it can help predict what's happening with the long jump. And our prediction equation is given to us right here. And they want us to find and interpret the residual for a sprint time of 8.09. And sprint time was our x, so I'm looking at x equals 8.09. So the first thing I want to do is figure out what the actual value is. So let's see if we have a sprint time of 8.09. So this is our actual value. Now I can plug this into my equation, and that'll allow me to find that predicted value. So I'd want to go ahead and multiply that 27.63 times 8.09. And then I'd want to take the 304.56 and subtract that value. And this gives me a y hat, which is my predicted value of 81.0333. So now when I'm calculating that residual, what I need to do is take that actual value (151) and subtract my predicted value. And I get 69.9667. Now this is a positive value, which means my predicted value was lower than the actual. So I underestimated. And what did I underestimate? I underestimated what's happening with the y. So I underestimated the long jump distance. By 69.9667 inches. So we found our A, we calculated our P, we then calculated the residual, and then we interpreted. Be careful, because they asked us to interpret, so if you're not being careful about that, you need to go through. Did we underestimate? Did we overestimate? What's happening there? Okay, we can also calculate we can calculate our linear regression with means and standard deviation. And so this is also known as our numerical summaries. Because sometimes there's just so much data that they're not going to give us all the data because it's going to take us forever to enter it in there. So what they're going to do is they're going to calculate the one variable stats for our data and then let us calculate the regression line. Now these formulas for calculating the slope and the y-intercept are in your formula sheet. So this is not something you have to memorize. You have to be able to do it because those formulas will be given to you. So again, this is when we're given numerical summaries. So those little print-offs that they give you that tell you n, which is the number of data points, our standard deviation, our mean, our median, our lowest, our first quartile. So the entire numerical summary, that information we can use. And so here's our regression equation. Y hat equals our intercept plus our slope times x. We can calculate slope by taking our R, or our correlation, and timesing it by the standard deviation of y over the standard deviation of x. And Sx is our standard deviation of x. We can calculate our y-intercept by taking our means. So this is the mean of my y and the mean of our x, and we plug that in. Why do we plug in the means? Is because the regression equation will always go through this point. It always goes through the mean of our x and the mean of our y. And so that's something else. These little details, they pop up in multiple choice questions all the time. So we're going to go ahead and walk through a problem. We have used Hondas, going back to those Hondas. The number of miles in thousands for 11 used Hondas car has a mean of 50.5. So this is the mean of my x value. Why? Because we used miles to predict the price of the cars. So my mean for x is 50.5. And my standard deviation for x is 19.3. Now the asking price has a mean, so those prices or response variable has a mean of 14.425. And a standard deviation of 1,899. And then they tell us that our correlation is negative 0.874. So now that we know that information, we can go ahead and work on calculating. So the very first thing we need to know is B1. Why do we need to know B1 first? Because I need B1 to calculate the y-intercept. So B1 is going to be our R value times the standard deviation of y over the standard deviation of x. And the thing that's interesting about that is, remember how slope is the change of y over change of x, or y2 minus y1 over x2 minus x1? That follows in suit here. Y's over x on those standard deviations. So now that I've calculated that, we get a y-intercept or a slope value of negative 85.996. Okay, now we're going to go ahead and we're going to move to our B0. So this is kind of plugging in the idea of that point x, our x mean and our y mean. Since it has to go through this point, I can figure out what my intercept is by even going back to that original equation, y hat equals b0 plus b1 times x. And instead of this, I have, because I know those can be in there. And then if I really want this, I can move this to the other side. And that is our formula right here for calculating that intercept value. So let's go ahead and figure those out. Y, our mean for y, 14.425, or 14,004, comma. That's not a point, that's a comma. And then minus negative 85.996 times my x bar, 50.5. And that's going to give us that intercept. And then we can write our equation. So now that I've calculated that, we've got 18,794.798. Now it's not exactly what we had when we did the regression formula, but it's pretty darn close, and it's close enough. So let's go ahead and write this out really quick. Y hat equals our starting value and then plus our slope times x. And there's our regression equation. A little bit nicer if we can just plug in all the values into our calculator, but again, there may be way too many values, so it's just time prohibitive to actually go ahead and enter in 150 different values to get the regression equation. Okay, explain what change in price we would expect for an additional 19.3 thousand miles. Okay, so this additional 19.3 thousand miles, this is checking how much would this increase. And so what we can do is our slope is actually our rate. It tells me for every 1,000 of miles, how is my price changing? So I can actually take this slope, what was that, negative 85.996? And I can times by that additional 19.3 thousand miles, and that will tell me how much that's going to change by just for those thousands of miles. And I don't have to worry about all the other information, because the other information will tell me how much it is at a certain point. I just need to know how much there's going to be a change, and that's why we have slope, which is a rate of change. It tells me how much it's going to change for this amount. I feel like I'm seeing the word change all the time. And so when I times this, I get negative 1659.7228. And so that means the price is going to drop $1,659.72 approximately for each additional 19.3 thousand miles. Okay, so let's talk about, because they're always thinking what ifs, what's going to happen, analyze what's happening here. So what happens if we take our variables and we standardize them? So to standardize, we change to these z-scores, which have a mean of 0 and a standard deviation of 1. So kind of bringing that back into your brain. So what happens is that we get this correlation times the standard deviation divided by standard deviation. Well, if they're both z-scores, the standard deviation's 1, so this really just becomes r. And so now we're seeing where our slope will be r when we're dealing with z-scores. Now our y-intercept is going to be our means plugged into that equation. So now all of a sudden I've got 0 minus my slope times 0. Well, anything times 0 becomes 0, and 0 minus 0 is 0. So now all of a sudden our equation for z-scores is this. Is this something you're going to have to do a lot of? No. Is it useful to know and be able to reference? Yes. Okay, so that's it so far. We've talked a lot about our residuals. We've talked about predicting, seeing what's happening, and we'll keep working with this, looking at other values that have to do with our regression equation.